Okay, the topic is going to be cubic functions. And before we get started with the notes, you need to know some things. Okay, here we have the graph of a cubic function. You're going to need to know how to graph this by pencil and paper, not calculator, and how to write the equation if I go ahead and give you the graph, but no equation. Okay, so to make it easier, let's look at some parts of the graph. You need to know that those are called roots, okay, and roots are also called zeros. So when we write the equation of a cubic, you're going to have to consider 3 roots, okay? You also need to know what your y-intercept is. Where does the graph cross y? Okay, and so if all I give you is a picture, obviously you can say it crosses y right there. But if I don't give you a picture, okay, you're going to plug in x equals 0 to figure out where it does cross y. Okay, because if you notice right here, x is 0 and y is right there. So every time x is 0, you plug that into the function, you're going to know what y equals. Okay? All right, now the next thing is we need to know how to draw this graph. If I have these 3 points and the y-intercept, I really need to know how's this going to curve. Is it going to come in from up here, or would the graph go down? Okay, those are the things we're going to look at right now. Okay, to determine how the graph is going to react, you're going to choose a number outside your roots. Any number you want to choose, but it has to be on the outside. Okay, so -6. If I plug -6 into the function, I will get a number that's positive, which all that means is my graph is going to go up after that root. Does that make sense? Okay, another example, if I choose a number -1, it's in between the second and last root. Okay, when I plug that into the function, my answer is positive, which means that part of the graph is going to be above x. That's all that means. Okay, and then finally here, I'm going to choose a number to the edge here, outside of the last root. I'll just choose 3. If I were to plug x equals 3 into the function, my answer would be negative. Okay, because my graph is below 0 whenever I go past that root. All right, so now let's look at some of this actually in motion. Okay, example 1, you need to know what the graph, the parent function, looks like for x cubed. Okay, here's what it looks like. Okay, this is a graph you must have memorized. Okay, since my function is cubed, that means that I'm going to have 3 roots. X minus R1, x minus R2, and x minus R3. Anytime your largest exponent is a 3, you're going to have 3 roots. What if your exponent was a 2? You'd have 2 roots. Okay? What if it was a 1? It's just going to cross x one time. That's your linear graph. Okay? If it was a 4, you'd have 4 roots, and so on. Okay? Now, sometimes my roots can count more than once. For example, look at that parent function. How many times does it cross x? Once. But it's a cubic. Where does it cross x? At 0. So in the parent function, okay, x equals 0 is called a triple root. It's called a triple root. So as we go along, you'll see more of those kind of examples. Okay, these next 3 steps are the 3 steps that you're going to repeat and follow in order to graph a function. Okay, you're going to need to, if you start with factored form, okay, then you're going to need to find your zeros, find your y-intercept, and test some values so you can determine if your graph goes up or down. All right, so how am I going to find the zeros? If I have factors, how will I find the zeros? You're going to set your factors equal to 0. Remember when you did that? Back in Algebra 1? or in Algebra 2 as well, okay? And then how will I find my y-intercept? Plug in what? What do I plug in for x? 0. Remember the graph we just looked at? Every single time, I don't care what the math problem is, your y-intercept, x is always 0. If you need to know what that is, plug x equals 0. Okay, and then the third step here, test some values to determine the direction of your function. Okay, there's 2 steps there. Just choose some values for x. Okay, choose some values for x. The values that you choose need to be outside or between the roots. Okay, then take those values that you chose and plug that back into your function to see if you get a positive or negative answer. All that's going to do is tell me if the graph is above or below. Okay, on example 1, the function f of x equal x minus 4 times x minus 1 times x plus 2. This is in factored form. So that's going to make it really convenient for us to determine what the roots are. Okay? To find the roots or the zeros, set each factor equal to 0. X minus 4 equals 0, so x equals 4. Okay, x minus 1 equals 0, so that means x equals 1. And the third one, x plus 2 equals 0, so x equals negative 2. Okay, so start by graphing those 3 points on your graph. Don't put those numbers on there. All right, so start by graphing your zeros first, 4, 1, and negative 2 for x. Okay, we know that the graph is going to cross in those 3 spots. Okay, but we also need to know where is it going to cross y? Or how am I going to find that? Plug in 0 for x. Okay, you go back to your original function that was given to you and replace all of your x's with zeros. Okay, so when I multiply that together, I get positive 8. So now I know that the graph is going to go all the way up to positive 8. It's going to go from negative 2 up to positive 8, back down to 1. Okay, I know that part, but what I don't know is how is it going to behave between 1 and 4? What direction after the 4 and before the negative 2? I don't really know that. That's where the testing comes in. Okay? Just make a number line there. Okay, your roots are negative 2, 1, and 4. So if I pick a number to the left of negative 2 and plug that back into the equation, or to the original function, I'm going to determine if it's positive or negative. I don't care what the number value is. I just want to know whenever I go over to negative 3 for x, am I going to go up for y or down for y in my ordered pair? So when I plugged in negative 3 for x, that was x minus 4. What's negative 3 minus 4?
Negative what?
Negative 7.
Yeah.
So all I really care is that it's negative, so I'm going to put a negative symbol. Okay, and negative 3 minus 1 is how much? Negative 4, so just put the negative. Negative 3 plus 2, negative 1. So when you multiply a negative times a negative, what do you get?
Positive.
And positive times negative. So the result is a negative number. Every number that I choose to the left of negative 2 is going to produce a negative answer. So that tells me that every part of the graph from this root in that direction for x is always going to produce a negative number, so the graph's going down right there. Does that make sense? Yeah. Okay? Now let's choose between root 1 and root 2 and 3. Okay, choose number 2. So 2 minus 4 is negative, 2 minus 1 is positive, 2 plus 2 is positive. The resulting product would be a negative number. Okay? So between those two roots, my graph has to be below because my answers will always be negative. Okay? My ordered pair, if x was equal to 2, I'd go over to 2 and I'd have to go down because it's a negative answer. Right? So between these two roots, the graph is going to be down. The negative, positive, and positive. 2 minus 4 is what? Negative 2, so I just put the negative. And then 2 minus 1 is positive 1, and then 2 plus 2 is positive 4. And then remember, your original function is factored, so they're multiplied. Negative times positive times positive. Okay? All right, and then finally, I'm going to test this point over here to the right so I can tell if I keep going up with the graph or do I need to come down. All right, so 5 minus 4 is positive, 5 minus 1 is positive, and 5 plus 2 is positive. So the graph, once I move to the right of 4, all my answers will be positive numbers, no matter if I plug in 5, 6, 7, whatever. You'll always get a positive answer. Okay? So that part of the graph is going to keep going up right there. Okay? So put all that information into your graph. Okay? It's going to go down here. I have to go up to the y-intercept, back to this root. We know it's going to be negative here and here, and then positive. Okay? So your graph's going to look like that. Okay, we're going to move on down to problem number 3. Okay, whenever you have a quantity squared, that means you have a double root. Okay, so the zeros, x plus 1 squared, you're going to do x plus 1 equals 0, so x equal negative 1. At negative 1, we have a double root. X minus 2 equals 0, so x equals positive 2. Okay, so we have another root there at positive 2. Okay, now we need to figure out where does it cross the y-axis. So I'm going to plug in 0 for x. So 0 plus 1 quantity squared times 0 minus 2. And 1 times negative 2 is negative 2. So my graph is going to cross y at negative 2. Okay, now I just need to determine how the graph is going to react outside my intervals here. So at negative 2 plus 1 is negative 1, and negative 1 squared is a positive 1. So I'm just going to put positive. And negative 2 minus 2 is a negative. So positive times negative. Okay, after I leave negative 1, when I go to the left, my graph is going to decrease because I get a negative product. Okay, now I want to test out a number to the right of 2. I'll test out 3. Okay, 3 plus 1 quantity squared is a positive number. And 3 minus 2 is a positive number. So positive times positive is positive. So after I cross 2, my graph's going to go up. So from negative 1 to my y-intercept to my 2, that's how it's going to look. On number 4, if you just look at it from the original parent function, which I have graphed in green, okay, we have a triple root here. So it's only going to cross x once. All right, so it was reflected and moved right 4. All right, so if you just take your parent function and flip it, 1, 2, 3, 4, okay, then it's going to cross x at 4, and it's going to have a y-intercept